All right, so this is building query for November 20, 2020. And the agenda at the start of the day was definitely going to be stats and possibly change report UI in desktop or in cloud, but I don't know if we made enough progress on that. I'll leave that to you, UB5. But
yeah. Yeah, we can totally talk about it. I'm going to quickly share I think we should definitely go through the bulk of Casey's work, which is the actual UI that we're going to be using for it. The thing that we haven't finished wiring up yet is the connecting the actual API backing so you can see a live report. And so today we can demo what the change report will look like based off some simulated or mocked response data. And then we can sort of talk through what the implications of that are and then timing around the last bits. Yeah, we've been working really hard on this change reports feature and some of the backing stuff for it. The big sort of theory here is that data sets can get really large, and before we dig in on actual like formal diffing of stuff, what we really want to be able to do is get a quick high-level overview of how much a data set changed or what aspects of a data set changed between two versions without needing to sort of get down to the row level. And so we think this is a little different from source code, where in source code it's just as natural to say, hey, 1,000 lines were changed. Let's just know what 1,000 lines. With a data set, we think it's much smarter to actually calculate the statistical aggregations of the contents of a data set body with each version, and then use that as a basis for fast comparison between two things. And so for that, we've introduced the language of a change report versus a diff, which is we sort of see as those two things being different. A diff would be a formal, hey, this is a script for turning one version of a data set into another, which maybe a human can read, or maybe a computer can just apply. And it's formal in the sense that when you apply a diff, if you use a diff like a patch, you will get exactly one thing out of the other side. Diffs are expensive to calculate when data sets are really large. And so in place of that, the thing that we want to use that is faster and much more common, which we anticipate we'll be using all the time, are these things called change reports, and change reports are based on stats. So I can quickly share what this looks like. We've made a lot of progress on this. This was Chris put together the initial mock-ups for this weeks ago. And so now we finally have like a real actual thing that we can click through and look at. So this, hopefully you can see my screen okay. Is that full screen now? Everyone see that okay? Cool. Yeah. So this is a change report. This is our storybook UI, which is where we develop. This is sort of the initial sort of landing ground and testing ground for a whole bunch of things inside of Query Desktop. So you can see we have charts here. This is like all the different types of components and things that we use and make and work with inside of Query. And the stuff we want to focus on, or specifically inside of Query Desktop. This is what we want to look at. So today, change report, I'm just going to full screen this, and we can sort of talk through what a change report is and what it's supposed to do. So in this case, we're comparing B-file World Bank population, and the left and right are two slightly different versions where they both have, can I hover these timestamps? So this is one at 6:02 p.m. on October 14th. And this one was, I'm going to guess, is also going to be, is 3:01 p.m. And so we can see very quickly here, we get an overview of the two different versions that we're comparing. We're comparing it against a data set against a prior version of that same data set. We imagine that you will be able to do change reports across any set of data sets. And so where that's really useful is if you're looking at a fork. So how has one data set that has deviated from another data set changed ever so slightly? Useful for that. And there's no reason that that can't apply. And so with all things in query data sets, they're broken down into components, and these components are sort of wired up as these toggleable tabs here. So here I have the README, and I'm just seeing a classic, what we would call a Unix or line-based diff between two things. We're seeing, hey, taken was turned into taken. This is the thing that changed, and then so line 3 is technically added and removed, and then we added lines 4 and 5 data set pulled monthly to the README of this data set. Moving on, the meta here, we're seeing that this from version 1 to 2, we actually just added an entire meta section. So we went from no meta to having some meta description, describe, description, and keywords. It's funny, describe is not actually a formal meta characteristics, but you can totally have that. Query supports arbitrary metadata. And then we can see in the structure here, we're actually just seeing like a very high level overview of the structure. But where things get interesting is this stats component. And so as we mentioned, calculating a diff is really expensive, but what we can do really easily is, and very quickly, is compare the stats. And so in this case, we're seeing a summary of changes first. We're seeing a change from 73.99.8K to 7,000, I can't say this, 759,200 entries. And so this is up 19,000 rows roughly, 19,500. And this is a change of very large, this is a 3.1 megabyte change. That's actually incorrect, right? Up from 101 megabytes to a gig. That's not the right calculation, but you get the idea. And then you see that we're going from 10 null values to 0. And so we get these nice sort of comparisons that give us these quick, okay, I know right off without actually looking at any of the data, 10 null values have gone away, the number of columns has changed, and the size of the data set has changed appreciably. And then what we can do is sort of give a more fine-grained look through all of this. I don't know why these are on the top, but we can actually compare each column A to B between the two dataset versions. And so we're looking at the column stats for the cases column, which is a numeric type. And we can see that the count is going up a whole bunch, which is in keeping with an addition of a number of rows. We can see the median max, and we can see the median moved a little bit between the two, and the mean moved a little bit as well. And so this is assuming that we get the sort of display of these charts correct. This would be the way to sort of really quickly see, okay, if I'm thinking about the cases column, I've got a couple of shifts that I've got to deal with. The line count is consistent with what I'm expecting. This is just a whole bunch of additions of rows. But shifts in the mean are really interesting and really useful for looking at. And so here we actually visualize for you what each mean, the actual histogram of it actually should look like. And so a histogram is just divide up all the values into a series of buckets and show the buckets as they are comparable. So we can sort of move through these super case, true, false, is sort of what we're looking at here. Again, we have a really big shift in the number of true counts. This is just showing what a shift would look like in a true false column. And then to finish it out, we have a combined location name, which went from a whole bunch of, again, we have the right number of rows added, the maximum length stayed exactly the same, and the number of unique values stayed exactly the same, but we have this like really large number of just empty string values added. And so immediately we know here that something has really shifted, where we had like a whole bunch of actual different values. We were seeing in this data set, we were seeing an assumption of Louisiana 206 times, the word assumption is actually a really bad example, which is actually a place. If we're looking at Bennock, Idaho, in the US, there are 206 versions of that. But in this case, we've now moved all of these to 4.8K of the empty string. That's very strange, 479. Oh no, that's actually exactly the same. So we know something's changed here. We need to dig in on the actual difference between the two. And then last but not least in this demonstration, we have a lat column, which did not exist in the left version and does exist in the right. And so as you can see in a change report, we are doing alignment of the columns and changing, okay, we have an added column here so we can see what these new values look like. And so that should track between added and subtracted columns. And those are just being matched based on the names of the columns themselves, which serve as identifiers. Yeah, and then rounding it out, we see here that we removed a transform script. And so every component of a data set is tracked inside of these change reports, but we get these nice sort of high level overviews of each of the actual columns themselves without digging into a formal diff. If we try to look at this as like a formal diff, we would be seeing thousands and thousands and thousands of rows of red and green. And so we think this is a much faster way to sort of look through that. Cool.
Can I stress test this a little bit? One of Chris's census data sets starts at 9,000 columns. Are we going to by default run one of these? Yeah.
No. Yeah, so there will be a maximum number of columns that this can display, and 9,000 obviously is not going to be in that number. And so that's for a number of columns that are that wide, we'll have to take something of a different approach. But in this first pass, I don't know what the highest number we will support when we do ship this is, but we'll basically say, hey, is this larger than, let's just pretend it's 200 columns. You know, if there's more than 200 columns, we're not going to show you the column stat breakdown.
Cool. Related question. I think by default, we'll obviously want to keep the leftmost column at the top of this list, but I will be eager to hear feedback from folks and hear if they recommend what I'm not proposing, but floating, you know, having a drop down of columns to choose from. Yeah, you just highlight the word cases. If I can punch that word cases and hit a drop down for all the columns and punch the ones I want or what, I could foresee them. Because someone's gonna be like, the state never changes, and I don't want this real estate being wasted at the top of my change.
And you can imagine if there's something really about the word columns that is then expressed as rows, which is really jarring, right?
Yeah, right. Yeah, I was also thinking like a little band across the top of all those columns, punch them, and that punch comes out or something.
Yeah, we may want to investigate different methods for comparing columns or displaying this. But yeah, this is sort of our first crack at it, and should serve as a basis for iterating on that kind of thing. Because I agree, there might be something we can do there, but it's kind of tough. Sometimes it's worth just asking the user to bend their brain around. Okay, this is a row of columns, a series of rows of columns to get them more real estate to be able to look at each thing. But we should definitely see if we can explore other alternatives. Do you others have thoughts on that? Cool. So I'm going to stop sharing. So the timetable for this kind of thing, we have done a lot of the legwork under the hood for this work and are in a really good spot to start shipping some of this stuff. And so I can anticipate that in the next week or two, we will actually have at least a release candidate to sort of start playing with some of this stuff. The last thing to do is just write the actual change report endpoint. The biggest stuff, a lot of the legwork that went into this was tuning the performance of query and then making the actual stats component a component, which is new. We now have the notion of stats as sort of a first order citizen in the query dataset universe, which I think is sort of a welcome change. We've been floating around, we've been toying with the idea of making a stats component for a number of months now, and we think we've finally gotten it down to something that's useful. If you're looking for a formal definition of the stats component, we should get that up in the near future. But the too long didn't read of it is query calculates the stats for you, and every column type has a specific corresponding stat type. Yeah. Anyways, with that, I think go ahead, Chris.
So that's stats is now, it's a component, but it's really read only, right? It's something that is calculated for you. There's no notion of like saving a stat.
Exactly. Yeah. So you can't provide a stats value. And so in that situation where you do want to provide your own statistical metadata, we'd heavily recommend using a stats key in the meta component, which is just a convention that we're sort of recommending to folks. You can provide your own stats. Meta supports whatever you want to put in there. And there's no reason that you shouldn't feel totally welcome adding your own stats values to the meta section of it. The reason that we make the stats component itself read-only is to create this comparability, right? We couldn't allow, well, we could, but it would get way more complicated if we wanted to allow users to provide their own stats and to try and allow all stats to be comparable. So we made a design trade-off and said, cool, if you want to do your own stats, provide them in the meta, and then we will automatically calculate these stats for you and keep them in the stats component form. Dustin.
How does this work with checked out data sets?
That's a great question. So this is sort of the latest area of research that we've been crossing over. And there's some funny implications to this. I'm glad you asked, Dustin. So the way it works the way I'm thinking it'll work is because stats are read-only, it's not like you're gonna have a stats.json file in your checked out directory. That wouldn't make a ton of sense. But you still want to be able to query get stats, and you still want to see stats on a working directory data set. To signpost a little bit, query has a notion of working directories into it to make query data sets work a lot like Git, so you can change directories and see the status of a data set while you're working on it. And so for that, we've long since had the notion of a stats cache, which is just, hey, for this given file, calculate this given body and the structure, calculate stats and give us the result. And then store that result in a cache because we don't want to constantly recalculate the stats. To calculate stats, we have to open the file, turn the file into structured data, and iterate over the entire thing, which is not that big a deal. If it's 100 megabytes locally, that's going to happen like really fast. But if it's a 25 gig data set, that's going to take at least a minute, if not more, right, to sort of open and iterate through that whole thing, depending on the speed of your computer. And so what we want to avoid constantly recomputing stats for that reason. And so for the FSI answer, to answer your question, Dustin, we're going to combine a stats cache with the mod time on your local machine and say, hey, you just saved something to this working directory. We're going to ask the operating system, hey, when was this file last modified? And if that last modified file was different than the mod time we have in the cache, then we'll recalculate it.
Is that cache stored in your repo? Is that how that works?
Yeah.
Okay. I have a suggestion.
Yeah, please.
Mod time may not be enough. There's this system called Redo that kind of came up with a solution for checking if the file is different. That is actually, you collect all of the relevant file system metadata, I guess, like about the file, like mod time, attributes,
Oh, cool.
et cetera, et cetera. And you just say if any of those change, you assume the file is new. And this avoids problems like clock skew or checking out a file using Git, which doesn't really apply here. But there's a bunch of like certain file systems like don't track mod time correctly or things like that. But if you just grab basically like the grab bag of
everything
stuff the file system knows, yeah, you assume that if any, like the inode number, if the file gets renamed, will have the same mod time, but like the inode number could change. Something like that. That's totally true. Something like that. Yeah, it could be interesting.
That's a great idea. Yeah.
Just handle some edge cases better.
Yeah, there was that great, I'm realizing there's that great write-up about how watching change files in operating systems is almost always done wrong, and just using mod time is incorrect. Yeah, we should totally do that. We could do, yeah, I'd love to sort of bring that chat offline, or
totally,
online, but off
to another conversation. Yeah,
Totally.
I also wonder if it's worth having a checked out file and just saying that it's read only, or like not like ignoring any writes to it. I don't know.
Yeah, maybe. I think it's worth experimenting with.
Yeah, it might be too messy. I don't know.
So the other reason that I'm initially at least writing a cache that exists inside of the query repo is for remotes and servers. So in a situation where you create a data set and we actually want to be able to have, eventually, I think this is actually a bit of a subject for discussion. The nice thing about stats is it aggregates, which sounds like a bit of a no-brainer, but it's actually quite powerful, right? You can take any kind of arbitrary tabular data and get information about it that is uniform, which is really good for the previewing side of the work that we do and understanding, hey, what is this data set about? I can see a world where Query.cloud really wants to display these stats, where a number of other places want to display these stats. And we want to be able to say, hey, the stats didn't come with this data set version, and so we'd like you to calculate them. But that can actually represent something of a weird, like, make your computer do a lot of work vector if we don't have a caching mechanism attached to a server. So if you can imagine, hey, calculate the stats on this 25 gigabyte data set, and then I just keep asking your server to do that, I can make it do work in a way that I don't want it to do. Or that's something we don't want to have happen. And that might be malicious, but it might also just be normal use, right? We might have lots of people asking for stuff. And so if we combine the notion of stats into a preview, we probably want to use a cache just to make sure that any of those big, large calculations are sort of usually done once and not repeated all the time. And so for both of those reasons, I think it's worth writing a decent caching layer. And it sounds like we should do it with redo instead of just mod times. That sounds like we definitely should. But yeah, and so those are the number of reasons why we sort of want to do it this way, is have the capacity to sort of cache things quickly. And I think that's a general pattern we're seeing a bunch as we sort of start to scale up the size of data sets that Query is working on. Anytime because we have this foundation in content addressing, we know when we have a version of something, we know it's never going to change. And so the cacheability of some of these expensive computations is really, really worth it. Another place where this pattern shows up, which doesn't seem obvious at first, but is really true, is like the DS cache work that you're working on, Dustin, or we could think about it as like DS lists, where extracting pieces of information from a data set can be quite expensive when just even opening up all those file descriptors can be quite large. So we're getting better and better at working with bigger data sets all the time. And I think this caching pattern is something that we're seeing emerge all over the place. So might as well name it and claim it and apply it wherever we can. But yeah, with that, that's kind of where we're at with change reports. Hoping to have these up on Query Desktop in the very near future, and then start talking about moving them to Query Cloud, and start talking about what it would look like to potentially leverage this new stats component in a number of other places, such as on Query Cloud. Dataset overview pages, I think, is another great place where we should start looking at this. Thoughts, comments, concerns, criticisms, foibles, questions?
No, just hard agree on there being a URL for these things, and being able to just drop that into Slack conversations or tweets and be like, look how many new rows there are in this thing.
Yeah, I think that's been a long time coming. To me, the general feedback feels like, when can we have it? And so we just got to go grind this out and get it done as soon as we can.
I mean, I also think the next, I think the next evolution, I don't know, like very obviously, as soon as you start messing with this, you're still going to want to drill down at some point. So I know that's coming eventually. People are going to say, oh, I want to, like, what is the actual value that changed?
Yeah, and I think what could be
that might be fun.
Yeah, but this might serve as a really nice jump off point and might help us save some work, because one world may be, hey, I just want to diff this column. And if that's the case, then that's a much faster and cheaper calculation than diff me everything, right?
For sure, yeah, that'd be wonderful. And just kind of, it's on demand, sort of smaller subsets of the diff, of the big diff problem. Love it.
I was going to add some pre-feed, I don't know. What we heard from some of our interviews a year ago in terms of, one frustration was I send a version to this data set to this team who works overnight in a different time zone. I come back the next day and sometimes I'm like, what changed? And then relatedly, I had a kind of another thought in my head. So that's the point of view of like somebody who's reviewing work that someone crunching data is doing. And then the second, from a former query user, looking at the number of rows and the number of columns to be the first test of whether the data has changed, and how imprecise that is. But at least I know that, like, I had observations for each of the last 1,349 days, and I did some changes, and I want to make sure I didn't lose any days, and I just need that. Just show me that 1,349 number. Yeah.
And that's I think that's really, if you think about like abstraction, right? It's like, and if you can only hold one number in your head when you're thinking about a data set, generally it's number of rows, right? It's like, oh, cool, this was roughly 250. And so when that number becomes 7,000, you're like, something is very different and I need to drop down a level. And so I think one thing, actually totally from what you're saying, Rico, is like, we've had that feedback from a number of users, and maybe making that number bigger, like just like 2,000 rows here, 2,225 rows on the right, I think would be a very quick win for our early mockups.
Really exciting though.
Fun, yeah, can't wait to get it wired up. Chris, do you have any closing thoughts?
I was thinking how this would be immediately, I'm thinking of the like live edit situation of like Airtables or Google Sheets, which I've done some recent work on, just trying to hack together like simple proto connectors, I guess, for query. But yeah, I want to be able to see like, okay, I touched this thing at 3 p.m. and then 4 other people touched it. And then when I come back into it to start editing and changing values, I just want to know like what's been going on. And these tools already have, some of them have these sort of like abilities to see who did what, but they won't really aggregate it. So this might be an interesting view on that, where I don't have to kind of follow along with the actual play-by-play that you get in like an Airtable change list, but like be able to just see high level might be more valuable. So I'm looking forward to seeing that, or maybe even like the demo of you know, tossing out, like sending a link to somebody, you know, having them make a bunch of changes, and then being able to sort of ground yourself before you even start asking them what's going on with it.
Yeah.
Might be fun.
No, I totally agree. And I think to that end, this sort of comes with the query Swiss Army knife style approach anyways, the same way that like other good examples like query validate, which will actually accept data that isn't versioned for, you can just say, hey, given this structure and this data that I'm giving you right now, please spit out the error report for this. There's no reason that we can't do the exact same thing with stats, where it's, hey, in an ideal world, it would be given this URL to the CSV encoding of this Google Sheet, please calculate the stats. And that URL, you can rerun that in a number of different places for like different applications that are outside of just versioning. I think that exact loop is what we will first see that with FSI linked directories in Query Desktop, where you can change the body file, and before you even commit, you'll be able to see the stats on how those changes will show up in the future. And then ideally we can sort of, if people want that wired up in other places, doable. But neato. Okay, I think that's it. I'm gonna go back to trying to get this thing done. Thank you so much, everybody. Have a lovely Friday.
See everybody in December.
Wow. All right, see ya.
See you, y'all.